here we are on 2.2c on page 35, doing adding and subtracting in scientific notation. Hopefully you're familiar from algebra with problems like this where we have a 4x plus a 2x, which will give us 6x. Easy enough, yes? Well, we can actually factor out the x, yes, if we want to, and we can take the 4 and add it to the 2 right here, and that will give us 6x. So it's the factoring out process that we are going to use. But instead of just having an x that we are factoring out, we are actually going to factor out the times 10 to the x in scientific notation. And this is going to allow us to add and subtract in scientific notation. Just before we get on with that, I want to point out that you do not want to try just adding scientific numbers in scientific notation on your calculator. You will get an answer, but you will not be able to figure out the number of sig figs because one of them might be times 10 to the 3, one might be times 10 to the 2, your answer might be times 10 to the 1. So your decimal is moving all over the place. And remember, when we're adding and subtracting, we are looking at the number of decimals. And if our decimal is moving, that's going to be a problem. So we are not just adding the numbers in scientific notation. We're going to follow this process that I'm going to show you here. Okay. So these examples are all in the worksheet itself. I've sort of written them over here so I can work them in real time with you. So here we have 4 times 10 to the 3 and 2 times 10 to the 3. And so we can actually factor out the times 10 to the 3. And we are left with these 2 bits here. Okay. So we have 4 plus 2 times 10 to the 3, and that's going to give us 6 times 10 to the 3. Straightforward enough? Okay. Let's try one where we have some decimals and the sig figs are actually going to matter. If we were worried about sig figs up here, 4 has 1 sig fig, 2 has 1 sig fig, and so our answer should have 1 sig fig. Now, I said that wrong. 4 is the uncertain digit, 2 is the uncertain digit, and that means that our uncertain digits are in the ones position, because of course when we're adding and subtracting, we're not looking at number of sig figs, we're looking at which position is the uncertain position. So we have the ones position, and then this is the ones position here. All right, so let us add these 2 numbers. Oh, I'm just going to pause for a moment so I can get a calculator. Why is it not pausing? Okay, this is super exciting. I'm not going to edit it. You're just going to have to fast forward past that little part there. Okay, so we're recording now. So now I'm going to factor out my times 10 to the 4. All right, so that's going to be times 10 to the 4. And we have 4.5 plus 1.75. Okay. And if we add 4.5 plus 1.75, we get 6.25. Now remember our adding and subtracting rule. We look for our uncertain digits, which is the 5 and the 5, in the tenths position and in the hundredths position. So that means that we have our uncertain digits in the in the 2 and in the 5. So we need to go to our first uncertain digit, which is the 2. We look to the right, that's a 5, which means we are going to round up. So we get 6.3. And of course, we still have this other half of the number, times 10 to the 4, and times 10 to the 4. So that would be our final answer there. Okay, So do the calculation using only the coefficients. Okay, that's the only part you're going to put on your calculator. Do not put the powers of 10 in your calculator. It will move the decimal place around, just like I said earlier. Just leave that out and do the coefficients only on the calculator and then round to correct sig figs. All right, next example we have here. And the thing that's different here is that our powers of 10 are different, which means my decimal has been moved to different places. So in order for the decimal to be in the same relative position for the two numbers, we need to make the powers of 10 the same. All right, so we're going to do this one. I'm going to take my 10 to the 3 and I'm going to change it into 10 to the 5. Okay, so we're taking 10 to the 3 and we're changing to 10 to the 5, which will make it the same as our other power of 10. If I do that to this number, I have made the power of 10 here bigger by 10 to the 2, which means the other half of the number has to get smaller by 10 to the 2, which means the other half of the number is going to become not 7.5. What am I doing? I have to make it smaller, which means I am moving my decimal place 2 places, 1, 2. Okay, and if I was to draw in those zeros, there would be a 0 here, there would be a decimal here, and there would be a 0 here. I know that's horribly messy, but let's just draw it out nicely. 0.075 times 10 to the 5. And then we're going to add that to our other number here, 5.25 times 10 to the 5. Just a quick note, these brackets on around the numbers in scientific notation, they're not necessary when you're writing the numbers on a piece of paper, but it does kind of make it a little easier to see that that's one number and this is our other number. Okay. Now remember, we're now going to, because our factor of 10 is the same, we can factor it out, times 10 to the 5. So we now have 0.075 plus 5.25. All right, we add those up, 0.075 plus 5.25. Remember, just putting in the coefficients into the calculator, excuse me, and we get 5.325 times 10 to the 5. We're not done yet because we need to make sure we have our correct sig figs. So there are uncertain digits. Remember, we're adding, so we're going to the first uncertain digit. We have one in the thousandths and in the hundredths. And so we're going to round to the hundredths position. So we look to the right, that's a 5. So this number is now going to become 5.33 times 10 to the 5, and we are all done. I'm going to recommend that at least when you very first start doing these problems, you write out all the work. The best way to get it wrong is to forget to write out all the work and then just, in your head you're doing something and it doesn't quite work. So just write out everything when you're doing these adding and subtracting in scientific notation. All right, next example. Here we go. Ooh, look, it's a subtraction. It's a subtraction and we have negative exponents. How exciting. All right, so we have 1.4 times 10 to the minus 5 and 5.67 times 10 to the minus 6. I am going to choose to change this power of 10 to match the other one. It doesn't matter which one you choose. I could have chosen to change my 10 to the 5, negative 5 into 10 to the negative 6, but I'm going to do it this way. I think it's going to illustrate something I want to show you in a minute anyway. Okay, so this one, we have to look at our exponent. It got bigger by 10 to the 1. And so the other half of the number has to get smaller by 10 to the 1, which means we will have 0.567 times 10 to the minus 5. We will now take 1.4 times 10 to the negative 5 minus 0.567 times 10 to the minus 5. And we are going to factor out the times 10 to the minus 5, which leaves us with 1.4 minus 0.567 times 10 to the minus 5. So here we go. We have our uncertain digit in the 4, and we have our uncertain digit in the thousands. When I plug those numbers into the calculator, we get 0.833 times 10 to the 5. Now there's two problems with this number as it stands right now. The first problem is that we need sig figs. And then the second thing we're going to have to deal with is we're also going to have to deal with scientific notation, because right now we have a 0 in front of the decimal, which means we're not in scientific notation. I want you to make sure that you do it in this order though, because I've been noticing that when people put it in scientific notation first, they can end up in trouble. I'll show you how that ends up being a problem in just a moment. But let's do it the correct way first. Let's round to our sig figs. So we have our tenths and we have our thousandths. Okay, so there's our tenths, there's our thousandths. And so we're going to look to the right of our tenths. That is a 3. So we're going to then round that to 0.8 times 10 to the 5. Okay. So now we have that in correct sig figs, which is only one sig fig, by the way. We are now going to transfer that into scientific notation. That means this needs to become an 8. And because this got bigger, the other half has to get smaller. So instead of 10 to the 5, it's going to become 10 to the 4. Okay, and that would be our final answer there. Let's see what happens if we did that in the other order. Let's say we put it in scientific notation and then sig figs, and see why that can lead to an error. Okay, so here's an error that's a common one. Common error. So we're going to start from 1.4 minus 0.567 times 10 to the 5, negative 5, and we got, oops, we're running out of room here, that's okay. We got 0.833 times 10 to the negative 5. Now, if you decide that you would like to change this to scientific notation first, you will get 8.33 times 10 to the negative 5. The problem is that then you might look and say, I have a tenths and I have a thousandths, and sorry, that wouldn't be 3 times 10 to the negative 5, that'd be negative 4. Oh my gosh, silly me. Okay, so regardless though, I have a tenths, I have a thousandths, and many people might say, oh, that means I've got my tenths and I've got my thousandths. Hang on. All of a sudden, instead of having that tenths and thousandths being the 8 and the 3, my tenths and my thousandths are the 3 and nothing. That's because we've changed the power of 10 to negative 4. So I have moved my tenths and my thousandths. They are not going to be the same as for these numbers, which are in the power of 10 to the negative 5. If you understand that, that's fantastic. If you don't understand why that's a problem, just remember to always do it in the order sig figs first, scientific notation second. Sig figs first, scientific notation second, because if you do it this way, you would end up with 8.3 times 10 to the minus 4, and that is just wrong because it should be 8 point nothing. Okay, just 8 times 10 to the minus 4. So sig figs first, scientific notation second. All right, one last example here. Let us do this one. 7.5 times 10 to the 3, 5.25 times 10 to the 5. Let's change this one here to 10 to the 5. That went up by 10 to the 2. So this other one is going to have to go down by 10 to the 2. Oh, no, we just did this example. I remember why we have this. Because there is another way of doing these problems. So I've shown you this problem before. Now I'm going to show you the other way of doing it. The other way to do it is to expand everything. Okay, so you could take 7.5 times 10 to the 3. Move your decimal place 1, 2, 3 places, which would give you 7,500. And we would take 5.25 times 10 to the 5, and we would move our decimal place 1, 2, 3, 4, 5 places. So we now have 525, 0, 0, 0. All right, we add those two, and we get, what do we get? Oh, I'm going to cheat and look over here, 533,000. Okay, so that equals 533,000. Our uncertain digits in the hundreds position and in the thousands position. So in the hundreds position and in the thousands position, which means that we are going to round our number there. We look to the right. Oh, that's a 0. Hey, easy peasy. And we get 533. Do I just stop the number there? No, because that would be silly, because I cannot take 533,000 and round it off to 533. I would be losing many, many powers of 10, 3 powers of 10. All right, and then this number is really big, so I might tend to put that in scientific notation, 5.33 times 10 to the 345. Okay, and that is that. There's another example on there if you want to look at it. I'm going to leave it there for now. You can do the practice questions. So method A, you can convert to the same power of 10. Method B, change it to standard notation. And remember, if you're changing to the same power of 10, find the sig figs first in your answer, and then not find the sig figs, round to sig figs first, round to sig figs first, and then scientific notation second. Thanks. Have a good day.